Good morning. Welcome to Physics Studio. We're on day 3 of our 4-day project on periodic motion, and you've already built your pendulums, and we had a lot of good designs. What you're going to do today is carry out your controlled experiment. So what I wanted to do was just take a look at some fine points in the measurement of length, mass, and time. And from there, you are going to develop your data table and take your data, and we'll see what kind of conclusion you come up with. So let's recall first the research question. What we're trying to figure out is which has a greater effect on the period of a pendulum, the length or the mass? And so obviously what that implies is you're going to carry out controlled experiments. If you want to test for length, you're going to control all the variables except for length and then systematically vary the length of your pendulum. If you want to test for mass, you're going to control all the variables and then systematically vary the mass. And from that, if you carry this out carefully, we should be able to tease out the relative effects. Now, this is the design I ended up with. I know in the first video I had books at the end of the pendulum, but I found that those introduce a lot of extraneous motion, wobble and spin. So I've gone instead with this, where I've got a fairly light chain and weights at the end. And if I pull this back and release, I get a pretty steady pendulum motion. Now, you all have come to appreciate some of the points of designing a pendulum, one of which is to reduce the wobble and spin. And a second one is that your chain or string should be light compared to the mass at the end. And the reason for that is the chain or string or rope itself has mass, right? So when you think about the true length of the pendulum, you have to consider that every part of this chain, every link is a certain distance L from the pivot point. And so it's contributing to what we call the length of the pendulum. And this length down here would be some larger length L. And so in order to get the true length, you would have to take the mass at the end times the length of the pendulum. And then you would have to integrate the mass of the chain across the length. Now, as long as you keep the mass of the string or the chain or the rope light compared to the mass at the end, you'll be okay, and you can forget about that. Now, let's start with mass, which is the easiest quantity to deal with. One way to deal with mass is to systematically vary something. Now, I've got washers here, right? I've got 5, 10, 15, and I don't know what the mass of one washer is or the mass of 5. But I do know that with this setup, what I effectively have is some M, then 2M, and then 3M. And that's perfectly adequate for graphing versus the period. Now, another way that some people are varying is similar, which is to take a container and put, say, a quart or a liter of water in it. And then by successively adding an equal amount of water, you get the same effect. You get an M, a 2M, and a 3M. Now, the other way is to take different objects, like, for example, wrenches, which is perfectly good, but we don't know the relation of the mass of this to this to this, so you would actually have to measure them. And your best bet is a good kitchen scale. They can be really accurate. If you use a bathroom scale, you're going to introduce a lot of uncertainty. So that's mass. Now, time, there's 2 considerations. Okay, first, let's put our pendulum in motion. Now, your first consideration with time is that you have to be able to identify the cycle. And you know that's pretty easy. All you have to do is take a point, any point in the cycle, like, for example, right there, and then watch till it returns, right? So start, 1 cycle. And that's how you identify the cycle. Now, the second point, though, and you'll remember this from circular motion, because this motion is so regular, you can actually take the time over more than 1 cycle and then divide. And that distributes the uncertainty of the time starting and stopping of the timer. So if I was timing, I might say I want to take the time for 4 cycles. So ready, start. 1, 2, 3, stop. And whatever time I got from that, we know that the period equals the time divided by the number of cycles. So whatever time I recorded for those, I would simply divide by 4 to get 1 cycle. And that's all you need to know about time. From there on, it's a matter of your skill. Now, the last point we want to talk about is length, and it's actually the most subtle of the questions. Now, the first thing we want to recall is that the length of a pendulum is not the length of the string. The length of the pendulum is the distance from the pivot point down to the center of mass of the object. And so our length for this one is from here to here. Now, that doesn't cause any great problem if you are able to attach your pendulum string or chain to the center of the objects, because it'll keep the center of gravity at the same, or center of mass at the same height. However, if you have objects that are of differing sizes, like wrenches, now the center of mass of this wrench is going to be about here, this wrench about here, and this wrench about here. If we were to tie these to the same length string, right, so that the top of each wrench was at the same distance from the pivot point, notice that the center of mass in successive ones is going to be dropping by quite a lot, an inch or more. And so that is significant. So what you would need to do is you would need to shorten the string for successive objects to keep the center of mass at the same length from the pivot point. So in each case, you would shorten the string slightly to keep that going. Now, it's similar in a case, for example, where you're filling something with water. So if we had this much water in here, our center of mass would be about here. And so if we hung that from a chain, we would call the distance from the pivot point to here the length of the pendulum. Now, if we were to fill that with a little more water, though, now suddenly our center of mass has moved up almost an inch. And so consequently, in order to keep the center of gravity at the same level, we would need a slightly longer chain here. And let's diagram that so that we can see, so that we're clear about this. Okay, so if we had a simple spherical mass at the end, our length would be from the pivot point to the center of mass of the sphere right here. And if we had a bottle of water with this much water in it, with the center of mass being about right here, we would need a length of chain or string about that long to keep that at the same L. So these two have the same length L. Now, if we fill that bottle of water a little bit more, that's going to change the center of gravity. And so we would need a slightly longer chain to lower that a bit in order to keep the center of gravity at the same distance L from the pivot point. So, insofar as you have different sized objects, that's fine. But you're going to need to pay attention to the length. That's really important to control for that. So beyond that, good luck. design a good systematic experiment. It shouldn't take you that long, but take care of the measurements, and I'll be really interested to see your results. So have fun today, and we'll talk to you later. Bye.